Swayam Prabha. Digital India. Educated India.
Namaste. We can calculate the measures of central tendency and dispersion, but it is also important to be able to graph these values to present our data graphically. Why is that so? Well, this is because graphical presentation is cleaner and it is clearer. It permits better understanding of data, especially so when we are dealing with large volumes of data. So, let us now look at some ways of representing data graphically. Let us look at this first example, stem and leaf plots. So, we have a set of data that is given by x equals 11, 12, 9, 8, 15, 25, 21 and 19. Suppose these were the heights of different saplings in centimeters in a nursery. We need to find out the most frequent or the common height. Stem and leaf plots are a quick way of discerning this. So, how do we make a stem and leaf plot out of this given data? Well, first of all, we need to define an interval width. Most commonly, we take an interval width that is a multiple of 10 or a fraction of 10. So, maybe we could take 10, 1, 10, 100 or so on, or we could even take 0.1, 0.01 or so on. For this particular distribution, an interval width of 10 looks as the most appealing one. Now that we have decided on an interval width, we divide this data, we take the smallest value which is 8 and we take the largest value that is 25. Now, 8 would come under a stem and leaf plot of 0. So, 8 can be written as 0, 8. We will have another stem that is 1 and another stem that is 2. So, now let us take these values one by one and start adding leaves to these. So, essentially what a stem and leaf plot is, that you have a stem, on that stem you have different leaves. So, this is how we are going to make this plot. So, consider the first value, that is 11. So, 11 comes under the stem of 1. So, we write 11 like this. Next value is 12. So, we write it as 2. Next value is 9, that is 09. Next we have 8, that is 08. Next we have 15, that is 15. Then we have 25, then we have 21 and lastly we have 19. So, this would be a stem and leaf plot. So, this makes it very easy to understand that most of the values lie in this interval width of 10 to 19. This is how we do it. The most common height is 10 to 19 centimeters. Next, we have a bar chart. A bar chart is useful for both categorical data and for ungrouped discrete frequency distributions. So, let us have a look at a bar chart. This bar chart in the example depicts the percentage output of 2 wood sawing factories in the first quarter. So, every chart needs to have the axes that are labeled, then it will have some values on the y axis and the x axis, then it will have a label, a y axis label and an x axis label, then it will have a legend which will show what all values refer to, and then it will have a title on top which tells us what this chart is all about. If possible, we also add scales. So, for instance, here you can add x axis scale and a y axis scale. This is especially useful if you are making a plot on a graph sheet. Now, going back to our bar chart, on the bar chart, here we can see that it shows that in the first quarter, that is the months of April, May and June, we have two factories, factory 1 as seen in the legend on the top right. So, the factory 1 is represented in blue color, the factory 2 is represented in green color. So, in the case of factory 1, we can see that the percentage output goes on increasing with the months. So, the output of May is greater than that of April and the output of June is greater than that of May. But in the case of factory 2, the output decreases from April to May and then increases again from May to June. So, a bar chart makes it very easy to interpret these data. It would be extremely difficult if we showed these data in the form of tables only. The next graph is called a histogram. It is used for continuous variables. It is similar to a bar chart, but the bars are joined together. So, for instance, suppose we had on the x axis, suppose we have distributions that go like this: 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and so on. And suppose these values were like this. So, here the values are joined together. On the other hand, if we had a discrete distribution, say number of children in different classes, number of pupils in different classes, suppose we had the values like 40, 41, 42, 43, 44 and suppose each class had a different value. Suppose this was grade 5, grade 6, grade 7 and so on. So, in this case we would not be able to join these bars together, but in the case of a histogram we join these bars together because it is a continuous variable. Another graph that we routinely use is a line graph. So, in this example on the screen you can see a line graph that represents the output of sawn timber from a sawing factory in the 4 quarters of 2016. Now, in all the cases we are not required to make bars on the graphs, but we can always take a central value and then join them together by straight lines to make a line graph. So, as we can see in this graph, the output increases from quarter 1 to quarter 2, then increases again from quarter 2 to quarter 3 reaching a maximum and then falls from quarter 3 to quarter 4. So, this is a line graph. A similar graph is a cumulative relative frequency polygon, also known as an ogive. So, an ogive can go on increasing or decreasing as we move towards the right. So, essentially you can have an ogive that goes like this, or you can have another ogive that goes like this. So, in one case the values go on increasing as we go towards the right, whereas in the second case the values go on decreasing as we go towards the right. So, if we look at the chart on the screen, we will see that if we look at the value, the x value of 40, we will get a y value of somewhere around 90. So, this means that 90% of all the values are less than 40 and only 10% values are greater than 40. So, this represents a cumulative distribution. So, essentially if we had a distribution of say 0 to 10, 10 to 20, 20 to 30, and suppose these had the values of say 5, 6 and 7, to plot an ogive you will make a cumulative frequency. So, this is the frequency and the cumulative frequency, this becomes 5, the next value becomes 6 plus 5, that is 11, the next value becomes 7 plus 11, that is 18. So, now if we plotted, so 10, 20, 30, and suppose this was say 5, 10, 15, 20. So, what are the values that are less than 10? We have 5 values that are less than 10. So, we take this point. Then how many values are less than 20? We have 11 values that are less than 20. And how many values are less than 30? We have 18 values that are less than or equal to 30. When we join all these points together, we get the ogive. Next, we have multiple bar charts. Now, multiple bar charts are deployed if we wish to show different kinds of data. The multiple bar chart that you see on the screen depicts the exports of softwood and hardwood from a fictional country called Fiction Land in various years. So, we can see on the x axis we have the years 2005, 6, 7 and 8. On the y axis we have the exports in cubic meters. The softwood is represented in green color and the hardwood is represented in blue color. We can make out that while the total exports have been increasing. Now, how do we make out the these total exports? By looking at the cumulative length of the bars with the green and the blues combined. So, total exports have been increasing and the exports of hardwood have also been showing an increasing trend if you look only at the blue portion. However, we can make out from this graph that the exports of softwood are showing a mixed picture, because between 2005 and 6 the exports decreased. They increased again if we look only at the green portion. The size of the exports increased again between 2006 and 7 and then they decreased again. So, multiple bar charts help us to show different kinds of data on the same plot. Now, when the variables might be related, we use scatter plots. So, in the case of a scatter plot, we plot one variable on the x axis and the other variable on the y axis. If there is a relation, we will observe a trend. So, let us look at some scatter plots. Now, this scatter plot shows height, that is represented on the y axis, and the diameter of trees. Diameter is represented on the x axis. In the case of sal forest of different site qualities, here we observe that as diameter increases, the height also increases, which tells us that both these variables are related to each other. And the common variable that governs both of these is the age. So, as the age of a tree increases, its diameter increases, at the same time its height also increases. So, if you plot diameter on the x axis and height on the y axis, you will see an increasing trend. So, both of these are related. We could also use a pie chart for visual depiction of data. So, for instance, this pie chart reveals the composition of a mixed forest stand. So, how do we make a pie chart? So, a pie chart consists of a circle and with a center O, and it is divided into a number of wedges. So, suppose we had 5 different data values, data value A, B, C, D and E, and the values were say 1, 2, 4, 5 and say 3. So, what is the sum of all these values? So, these are the frequencies in which these data appear. What is the sum of it? So, you have 5, 3s are 15. So, to find out the angle that is subtended by each of these A, B, C, D and E on the pie chart, we divide the frequency by by this total 15. So, you have 1 by 15, 2 by 15, 4 by 15, 5 by 15 and 3 by 15. Now, remember, when you have a circle and if you have this radius that goes all around, it makes 360 degrees. So, if we wish to figure out how much is the angle subtended by any one value, say A, we multiply these values by 360 degrees. And the value that we receive out of this would be the angle that is subtended by A in this case. So, here we observe that every tree species has been given its own wedge, and the wedge angle is calculated by the value of the sector divided by the sum of all values and then multiplied by 360 degrees. So, the total in this case will always come out to be 360 degrees. Now, representation of data in the form of charts is important, because suppose I gave you a distribution of x equal to 1, 2, 3, 2, 2, 3, 5, 6, 10, 11, 3, 4, 6 and so on. Suppose I gave you a large distribution, and if I asked you to find out a measure of central tendency, suppose I asked you to find out what is the mean in this case, it would be extremely difficult, because it will be computationally intensive. On the other hand, suppose I gave you this distribution and we have these values of 20, 30, 40, 50 and suppose this is how your curve looked like. On the y axis also we have say 100, 200, 300, 400, 500. Now, if I ask you what the mean was in this particular case, in this case it would be computationally intensive to calculate the mean, but in this case you would be very easily saying that the mean is close to this value. So, the mean would be close to around 32, and if I asked you how many values of y corresponded to this value of x, you would very easily tell me that it would be somewhere around 450. So, this makes understanding of these data very intuitive. On the other hand, suppose I gave you two distributions. So, this one was x1. Now, if I have x2, that is again to give some random numbers 2, 3, 4, 5, 1, 2 and so on. And if I asked you which of these two data sets is larger and which one is smaller, again it would be difficult. But suppose we plotted x1, so this is x1, and suppose we have another distribution, or let us make it in different color. Suppose this is x2. So, in this case, if I asked you which one is which data set has values that are larger than the other, you would be very easily telling me that x2 is greater than x1. In fact, it is way greater than x1. Similarly, if I asked you what is the spread of these data, so if I asked you the range or the range coefficient or say the standard deviation of x1 or x2, it would be difficult to tell intuitively. But suppose if we plotted these and we had this as x1 and say this was x2, you would be very easily telling me that in the case of x1 the spread is greater. So, the standard deviation is greater. as compared to in the case of x2. So, even though we are not getting to the exact values of the measures of central tendency or the measures of dispersion, we can very intuitively tell something about this data, which has a larger mean, median or mode, and which one has a larger or a smaller dispersion. So, this makes a representation of data in the form of charts very important in our understanding. Thank you for your attention. Jai Hind.